Ukraine just built something so durable, so technically ingenious, and so profoundly disruptive that it has effectively rendered entire categories of Russian electronic warfare obsolete. This is not a slight upgrade to an existing platform. It is a fundamental shift in combat survivability. In the span of just 6 months, a team of Ukrainian engineers transformed a vulnerable drone platform into an unkillable asset, achieving a 92% mission success rate against advanced Russian jamming environments. This changes everything, and even the most hardened NATO defense planners are now scrambling to replicate this exact capability. Welcome to States News. If this is your first time here, subscribe and turn on notifications immediately, because what we are about to break down is not just a technological story, it is a glimpse into the future of modern warfare. By the time we are done, you will understand exactly how Ukraine bypassed a decade of Russian electronic warfare development and why this specific innovation is currently being prioritized by defense ministries across the Atlantic. I am going to show you exactly how this unkillable platform functions, the specific technical hurdles the engineering team had to clear, and the massive second-order consequences this will have for global military strategy. We will cover the specific signal processing architecture that makes the system immune to standard localized jamming, the strategic background of the ongoing electronic warfare conflict, and the geopolitical implications of this technology shifting from Ukrainian workshops into the broader NATO arsenal. By the end, you will understand why the current balance of power in contested airspace has just shifted, and why Russia's most expensive jamming systems are suddenly finding themselves looking at a very expensive, very ineffective piece of hardware. To understand why this development matters, we must first look at the strategic environment. For years, the Russian military has invested heavily in a tiered electronic warfare doctrine, centered on the Lear-3 and Krasuka-4 systems. These platforms were designed to create a blanket of electromagnetic interference, effectively blinding enemy sensors and cutting off command and control links. The strategic objective was simple: dominate the electromagnetic spectrum to isolate enemy units on the battlefield. The Krasuka-4, in particular, was marketed as having a range of up to 300 kilometers, capable of disrupting radar and satellite communications. This doctrine created a massive hurdle for Ukraine, as initial drone operations were frequently disrupted, forcing reliance on satellite-linked systems that were both expensive and vulnerable to high-altitude jamming. The actors in this drama are clear. On one side, you have the Russian Electronic Warfare Command, which has spent the better part of a decade refining its jamming techniques based on lessons learned in Syria and the early phases of the invasion of Ukraine. They operate with a centralized, top-down approach that relies on high-power, high-signature emitters. On the other side, you have a decentralized, agile network of Ukrainian engineers and civilian contractors. These teams operate with minimal bureaucratic oversight and a singular focus: tactical survivability. They possess limited hardware budgets but possess significant expertise in software-defined radios and signal processing. The constraints they operate under are extreme: constant risk of airstrikes, limited access to high-end chips, and the need for rapid iteration. The baseline facts are critical. Standard drone communications typically rely on specific frequency bands, usually 2, 4 GHz and 5, 8 GHz. These bands are notoriously crowded and easily jammed by high-power oscillators. Prior to this innovation, most tactical drones were vulnerable because their hopping algorithms were predictable. Furthermore, the reliance on GPS for navigation provided a secondary point of failure. When the GPS signal was spoofed, the drone would either lose its way or return to home prematurely. What the Ukrainian engineers discovered was that by shifting the communication link to a non-standard frequency, combined with an AI-driven, localized navigation system, they could maintain control even in a total signal denial environment. This is not just a tweak, it is a fundamental re-architecting of how a drone interacts with its operator and its environment. Now let us look at the development itself. The core of this unkillable platform lies in its proprietary frequency hopping spread spectrum, FHSS module, which is significantly more advanced than standard commercial off-the-shelf components. By utilizing a wideband transceiver that scans the spectrum in real time, the drone automatically detects the jamming frequency and shifts its control signal to an unoccupied narrowband window. The tactical significance is immediate. The operator retains full control of the vehicle, while the Russian jamming emitters are essentially shouting into the wind. The drone is no longer a passive target waiting for a signal. It is an active participant in managing its own electromagnetic environment. But the tactical significance is only the beginning. The strategic implications are profound. If a low-cost, mass-produced drone can ignore a multi-million-dollar jamming station, the entire cost-to-benefit ratio of electronic warfare is inverted. Russia's heavy investment in systems like the Krasuka-4 is rendered less effective. potentially forcing a shift in how they allocate their finite defense resources. Furthermore, the ability to operate in contested environments allows Ukrainian units to maintain persistent intelligence, surveillance, and reconnaissance (ISR) capabilities, effectively denying Russia the ability to hide assets behind an electromagnetic shield. The second-order effects on alliance structures are already beginning to surface. NATO defense officials, including representatives from the UK's Defence Science and Technology Laboratory, have noted the extreme efficacy of this software-based resilience. There is a growing consensus that the future of drone warfare is not necessarily in higher power transmission, but in the software-defined agility of the platform itself. This knowledge is currently being codified into new procurement requirements for Western drone programs. The economic impact is also noteworthy. By avoiding the need for expensive, heavy shielding or complex, long-range satellite data links, this Ukrainian-designed module keeps the total unit cost significantly below Western-manufactured equivalents. As we look at the broader geopolitical consequences, it becomes clear that this is an inflection point for the defense industry. Nations that have invested heavily in traditional electronic warfare might find themselves lagging behind a new generation of software-first systems. The focus is shifting towards signal resilience, decentralized networking, and autonomous navigation in GPS-denied environments. This technology validates the Ukrainian engineering model, rapid iterative development driven by the immediate desperate requirements of the battlefield. It is an approach that prioritizes speed and adaptability over the multi-decade procurement cycles that define many Western defense projects. This brings us to the complications. It is vital to acknowledge that this technology is not a panacea. The system still requires a line-of-sight or near-line-of-sight connection, meaning its effective range is still constrained by the terrain and the altitude of the relay point. Furthermore, as the electronic warfare landscape evolves, Russia is likely to respond with more advanced cognitive jamming techniques that utilize machine learning to predict the hopping patterns of these drones. The arms race in the electromagnetic spectrum will continue to escalate. There are also significant challenges regarding the mass manufacturing of these modules at scale while maintaining rigorous quality control, particularly given the global semiconductor supply chain constraints. We must also consider the perspectives of those outside the Western military context. In Beijing and other capitals, observers are likely scrutinizing these developments with intense interest. The lesson they are learning is that the reliance on massive, high-signature EW platforms is a vulnerability, not a strength. The shift towards smaller, distributed, and resilient systems is likely to become a central feature of military doctrine for major powers over the next decade. The core question remains: will the transition from this Ukrainian innovation to a mass-produced Western platform retain the agility that made it successful in the first place? History suggests that the integration of such technology into established bureaucratic procurement processes often leads to cost creep and overspecification. In conclusion, Ukraine has not just built a better drone. They have demonstrated a new paradigm of electronic survivability that the rest of the world is only now beginning to grasp. The success of this platform, characterized by its frequency, agility, and autonomy, represents a fundamental shift in the tactical and strategic landscape of modern conflict. The reliance on legacy electronic warfare assets is increasingly looking like a strategic liability, and the pressure on defense contractors to integrate these resilient software-driven solutions will only intensify. As we look ahead, we should expect to see these principles of signal resilience and autonomous navigation become the baseline requirement for any serious military-grade drone system. The era of the jam-proof asset has arrived, and it is a development that will define the battlefield for years to come. The world is watching as these lessons from the front lines are rapidly adopted. The integration of this technology into broader defense frameworks will likely be the next major focus of military innovation. This channel will continue to monitor the specific technical iterations of these systems and how they impact the evolving balance of power across the globe. Stay tuned as we track how this and other critical developments fundamentally alter the course of modern geopolitical events. We provide the analysis that others miss, keeping you informed on the developments that truly matter. Subscribe, hit that bell, and stay tuned for the next deep dive into the technologies shaping our future.